Hey everyone, so we'll continue with the functions today. Probably one more class on functions. And today we're going to talk about polynomial functions, and then we're going to talk a little bit about compositional functions. So let's first start with polynomial functions. So they are exactly as they sound. They are polynomials in functions. So we saw what polynomials are, expressions with numbers and variables without. So polynomials don't have negative powers. They don't have, for example, variables in the denominator, also no radicals or powers that are not whole numbers, no powers like 3/2. So polynomials basically don't have any of this. So polynomials without this. And to make a polynomial, to make it a polynomial function, simple. So we take some polynomial, would be a monomial, binomial, trinomial, all sorts of polynomials. For example, x to the second plus 3. That's a binomial of degree 2. And to make it a function, simply give it a name. And of course, whatever variable is in the polynomial is the variable we put here in parentheses. So as we saw last time from the function notation, this is the name of the function. This is the variable. And of course, this is the expression. So the expression here is a polynomial. Okay, so that's basically what a polynomial function is. There is a function, and there is an expression, a polynomial, and it has a name. And whatever we did last time with functions, graphing and domain, range, and everything applies to this. Again, these are simpler because they don't have this, they don't have this, and this, and so on. So that's why they're relatively simpler. But functions could have any of these. But polynomial functions only have polynomials in them. And again, polynomials don't have any of these terms, as we learned before when we talked about polynomials. And the name changes. The name could be any letter, F, J, G, K, whatever name we give it. It's just a name and a variable and some expression. Again, the expression here could be any variable. It could be X, Y, A, B, C, whatever. The variable here is, it's also the variable we put in parentheses. So f of x, x being the variable that's in the function. So that's basically what a polynomial function is. And whatever we did with the polynomials last time, we added, we subtracted, we multiplied. All of that applies to polynomial functions. So, for example, we can add and subtract polynomial functions. It's very simple. So we need at least 2 to add. For example, f of x is maybe 3x to the second minus 1, and another one or more, maybe 4x to the second plus 3. They happen to be, they could be a trinomial. It doesn't have to be, they don't have to be both binomials or trinomials. It could be a binomial and a trinomial. So with these two, we can do whatever we want, basically. We can add them, subtract, multiply, divide, do whatever we want. Let's maybe make this one, let's make it like this instead. It's a lot simpler. Maybe something like this, just to make things simpler a little bit. So we can add and subtract these very easily. So for example, f plus f plus g of x. this notation here, it just means we're adding two functions together. And this does not mean a multiply by x. It does not mean a multiply by x. It just means of x, or the variable that these two have. So we add the two functions together. And again, this is not a multiplication. It just means f plus g of x, which means both variables have the letter x. Both functions have the variable x. And when you see this, it simply means f of x plus g of x. Very simple. And to do that, we simply add the two functions. So we take f of x, which is this, and plus g of x, the other function, which is this one, 5x plus 2. So we've done this addition and subtraction over and over again with polynomials, with algebraic expressions. Same thing applies when we have functions. Basically, we're just naming polynomials. We're giving them names, and that's all there is to it. And to add these, again, we combine like terms. So it's going to be 3x to the second plus 5x. We combine these two together, it'll be plus 1. So that's how simple it is to basically add two functions, or this could be any operation, could be subtraction, multiplication, whatever operation it is. Let's say, for example, subtraction, maybe g this time, g minus f. Okay, g minus of f minus f of x, g minus f of x. All it means again is g of x minus f of x. The g of x goes first, so I'm going to write this one first. And with subtraction, we're going to need parentheses, just like we did with polynomials. So g minus f of x. So whatever polynomial comes, or function that comes after the minus sign, it has to be in parentheses. So f of x, 3x to the second must be in parentheses. And then we'll simplify just like we did with the polynomial functions. So what do we do here first to simplify this?
To open parentheses.
We need to, that's right, distribute. So we're going to distribute this first before combining like terms. So this stays the same. So negative times 3x, negative 3x to the second. And then negative times a negative will be plus 1. And again, combine any like terms. Only like terms to combine are these two. So this stays the same. I'm going to write it first. It has the highest power, followed by positive 5x. And of course, 3. Again, we just add in and subtracting like adding polynomials, because these are basically polynomials with names, polynomial functions. You could also multiply. Okay, so you may see f times g, or you may say just fg. Fg also means multiplication. So this is a subtraction, but this is a multiplication. Again, just like multiplying polynomials. So this means f of x multiply g of x. So f of x goes first. I'm going to put it in parentheses, so it's a binomial. This is like multiplying the binomials we did last time. So the first one in parentheses, the second one also in parentheses. So f times g. G is 5x to the second. And again, just distribute and combine like terms. So this is 15x to the third, then 6x to the second, negative 5x. We did this over and over again. Negative 1 times 2, that's negative 2. There are no like terms to combine here, that's fine. So that's the product. That's the product of these two. There's no like terms to combine. For division, we will do that later. We're going to learn how to divide functions. For polynomials like these, I'm going to learn how to do that later. And that's basically all there is to it. So remember these notations here. When you see something and a function, an operation, another function of x, again, this doesn't mean multiply by x, it just means of x. If you split it, if you want to split it, it means f of x plus g of x or minus or whatever. Then you just replace the functions. F, whatever it is, plus here. We need parentheses when we subtract or multiply. No need for parentheses when you add. Just put all the terms and combine the like terms. Okay, so that's basically how you multiply, add, subtract polynomial functions. They're basically polynomials. And also here we said add, subtract, and even multiply. Okay, so we pretty much we did all of them here. So we just combine like terms or multiplying. Before we go to the next thing, evaluation of this. Any questions about this, everybody? Adding and subtracting polynomials, multiplying. Everybody?
Can you please go up? I need to take a screenshot, please.
Mhm.
Okay.
Okay.
All right, thank
Any
you.
questions, everybody? Please let me know if you have any questions. Again, these are just some simple additions and subtractions, nothing much. So remember the notation again. All it means is add the two functions. It does not mean multiply by x. This is not a multiplication. It just means of x. It's like we say here, f of x. Here we say f plus g of x, meaning that's the variable they both have. Now let's see what happens if you have a number. Sometimes you have a number here instead of x. So if you have x, this is what you do: add, subtract, multiply. Other times you may see a specific number here. So that's when we evaluate the polynomial functions, just like we did before with linear functions, quadratic functions. So let's take the same problem here. So it's f plus g. Instead of x, let's say of some number, maybe 2. Again, this does not mean times this by 2. This is not times 2. It just means f plus g of 2. Just like we did here, we split it. So we split this into f of x plus g of x. Here, we can also do that. So this means f of 2 plus g of 2. That's all there is to it. And then again, we know how to find f of 2, and we're going to add it to g of 2. We're going to evaluate basically each one separately and add what we get. And then we sum up what we get. So what is f of 2? How do we find f of 2? Knowing the function here. Everybody, how do we find f of 2?
Are you multiplied by the value?
We can either
F of 2. How do we find f of 2?
So you
we plug into the
replace
F function.
x. So you say the fx. So instead of x, you put 2. You
Where
place
in the function f, right?
yes, on the function.
This is what we did when we graph functions. That's right. So f of 2. So we're going to put 2 here. So it's going to be 3 times 2 to the second minus 1 and plus
G.
Plus
Is
g
that
of 2.
5x?
That's right.
5.
This time we're going to put 2 in g.
5 multiplied by 2 plus 2.
Okay. That's right. G of 2. It means put 2 in g. This is g. We put 2 here.
Yeah.
Replace the x with 2.
X by the number.
That's right. So again, evaluating just like we did last time when we graphed functions. Now we just need to simplify this. So when you have a specific number here, that means we need to plug that number into the functions and then add or subtract. So we need to simplify this. So we're going to do
11
the
plus
exponent.
We just put a number instead of x.
Yeah.
That's right. Put a number.
By the number. X by the number.
Okay.
So we evaluate. So now we're going to simplify this. So this is 2 to the second. That's 4,
Yeah, 4
times 3.
12.
That's 12 minus 1 is 11.
11 plus 12.
That's right. 5 times 2, 10 plus 2 is 12. And that's 23. So when you evaluate, if you have a number here, the answer is a number, specific number. But if you have x, the answer is a polynomial like this, because we just add in the terms, add in the functions together. So if you have a specific number, it means that number you need to plug in both functions, just like we did here, and evaluate each one, then basically just simplify. And same thing works whatever the operation is here. This could be a subtraction, it could be a multiplication, it could even be a division. So it works the same way. And let's do another one. This time maybe g, maybe with a minus. So g minus f of some number, maybe let's say -1, for example. Okay, g minus f of -1. What does that mean?
So you're gonna replace x by
We
x by
subtract f
-1.
from g and we plug -1 into the x.
That's right. So it's going to be basically we're going to plug the -1 here. So it's going to be, if we split it, it's going to be g of -1 minus this minus here, f of -1.
Professor,
Same thing.
is it okay if we firstly subtract the functions and then we plug the value?
You may do that. You may do that. That's fine. Or you can just evaluate right away. That's fine too. So g of -1. So -1 goes into g. So -1 into g. Make sure you use the right function. G is here, so it's going to be 5. Multiply -1 plus 2. And a minus. Again, whatever comes up after the minus has to be in the parentheses. So this is very important. Whether it's a function that comes after the parentheses or some evaluation, it must be in parentheses because the minus will affect everything inside. The minus will affect everything, not just the first term. It's going to affect everything.
Change the sign.
And then, so we're going to do -1 into f. -1 into f. That is f again, so -1 will go here. So 3, -1 to the second, minus 1. Again, the rest is just simplifying. So we're going to do the parentheses first. Let's evaluate inside the parentheses before we do anything else.
Yeah, 2.
So when you evaluate the parentheses, so we're going to do the exponent first. That's 1. -1 to the second is 1. Times 3, that's 3. Minus 1 would be 2.
Yeah.
That's right. After the parentheses, we're going to do the multiplications. This multiplication and this multiplication. So this will be -5 plus 4. And this is -1. Okay, so that's the evaluation. So when you evaluate again, the answer will be a number, not an expression with x, but just a number. So addition, subtraction, same thing if it's a multiplication. Will work the exact same way. So let's do 1. We sum it f times g or fg. Fg of some number, maybe 3. So fg of 3, just like here, if we have x, it means f of x times f of g. If you have a number, you put that number here. So this will be f of 3 times g of 3. And again, we're going to put 3 into f. 3 into f means 3 is going to go here. So 3 to the second minus 1 times. So this we need to put in parentheses. So we're going to put these in parentheses or brackets, the first one, and times. The other one also needs to be in brackets because they both have multiple numbers and operations, so we can separate them with parentheses. So g of 3, so 3 goes into g. This is g, so we're going to put 3 inside of it.
The plain parentheses.
I'm sorry, say it again.
Why we have to put this one, this parentheses, not the regular?
You can use the regular ones. This is just to avoid confusion with the regular parentheses inside. But if you use the regular one, that's also fine. These are usually basically just bigger parentheses. The brackets are bigger parentheses. So now we can focus inside of these. until we're done, and then we multiply what we get. So each one is going to be done separately. So the first one, 3 to the second, that's 9. 9 times 3, that's 27. Minus 1 will be 26. We can now go back to use the regular parentheses. Then we do the same thing here. Do this one here. 3 times 5, that's 15, plus 2, that's 17. And finally, multiply these two. 26.
442.
What is it?
442.
442. Okay, so again, whatever the operation is, you go ahead and do it. You need parentheses with subtraction and multiplication. No need for parentheses here. It doesn't really change anything. Also, no need for parentheses here. The last thing we didn't do the division here, but we can definitely evaluate with the division. We didn't do the division of polynomials. We'll do that sometime later, but we can definitely evaluate the division. For example, f over g of, so instead of multiplication, we have a division now of some number, maybe -2. Okay, we can split this again, just like we split the subtraction, we split the multiplication. So we can do f of -2 over g of -2. And again, we're just going to evaluate whatever this is and this and divide them. So f of -2. So we'll plug, so that's f 3x to the second. So we're going to plug -2 here. So it'll be 3 -2 to the second minus 1 over g of -2. So -2 goes into g. It is g again. I'm going to plug -2 here. So 5 times -2 plus. And again, the rest is just simplifying using the order of operations. So we'll do the exponent first. So -2 times -2 here, that's 4 times 3, that's 12, minus 1 is 11. Over -2 times 5, that's -10, plus 2 would be -8. And that's it. Reduce the fraction if possible, simplify it. If not, that's fine. This case doesn't reduce, so that's the answer. So it's very simple to basically deal with the polynomial functions. All you're doing is adding and subtracting, or if you have a number, you plug it and you evaluate in functions. So it shouldn't be that hard. Just like we did before, we did it with the expressions. We did it with polynomials themselves. Today we did the same thing basically, but under a different name, polynomial functions. So technically just polynomials. Okay, so all this is some basic adding and subtracting. Okay, everybody, any questions about any of these problems? Okay, so I just wanted to go over that because sometimes you see these notations in the book or something. They're pretty simple. This is all they mean. Just add and subtract, multiply. Any questions here before we move on, everybody, to a more interesting topic?
We got it.
Okay, everybody else, please let me know if you have any questions. So that's what I mean by polynomial functions. They're just polynomials. Whatever we do with polynomials, we can do with them. We can also graph them when you see polynomial function. We can graph them, like I said. We can make tables like we did last time, do the domain, the range. Everything we've done with polynomials applies to polynomial functions. And now, this is more interesting here. We're going to talk about composition of functions. So basically another operation we can do with functions. As you can see here, we added functions, we subtract them, we multiply, we can also divide them. The other thing we can do is composition of functions. So composition of functions All it means is we're not adding two functions or subtracting them or multiplying them. We're actually putting a function into another function. See here how we plug, for example, 3 into f, or plug -1 into g. Here, with the composition of functions, instead of putting a number into a function, we actually put in a function into a function, something like this. So it's not f of some number, but f of some function g. And we take a whole function, we plug it into the other one. So we say f of g. So we say f of g. Okay, so we plug a function into the other, basically. We take a whole function, we plug it into another. Let me give you an example of that. So we're going to need two functions. So let's say, for example, for x is 3x plus 1. We're going to need another one. We're going to need at least two to find a composition. And let the other one be maybe, let's say 4x to the second, for example. F and G. So let's find the composition of the two. The notation of the composition is actually like this. F, and then a little circle in between, and G. Could be like this, or usually we write it like this. So we saw before, this could be addition, subtraction, or a dot for multiplication. Not this one, this is not a multiplication, or it could be division. So when you see this, that means a composition. So that means it is not a multiplication, it is a composition.
Is it O or is it circle?
Just a little circle, small circle, not O. It's a little small between the letters. So here's how we say this notation. So we say f of g of x. F of g of x. Because we said here, this is f of g. Okay, f of g, f of g. So this one we say f of g of x. Okay, f of g of x. Again, this does not mean times by x. It just means that's the variable that they both have. So, so f of g of x, or we can say f composite. Another way of saying it, say f composite g. F composite g. So just a notation. So don't confuse this notation with this one. Okay, so again, this is a multiplication. This is what you do. Just multiply the two. If you see a little circle here, that's what how you know it's a composition, not a multiplication. In a multiplication, we multiply the two functions. But in a composition, we don't multiply them. We actually plug one into the other. We plug a whole function into another. Let's see how to do that. So this basically equals, like I said, f of g. So f of g, as if g was a number, as if g, for example, was some number. So you're going to plug that into this. The way you do it is pretty simple, same way you do with the numbers. So into the function f, we're going to put g. This is f, and the g going to go into it. So what you do is you write the first one. We're going to write the first function without the x. And instead of the x, we're going to put the whole other function. So let's write the first function f, which is this one. And again, just leave the x blank. So this is f without the x. And instead of that x, just like we did earlier when we plugged 2 or 3 instead of x, here, instead of this x, we're going to plug the whole function g, which is 4x to the second. And that's it. That's basically how you find composition. That is the composition. You can simplify it a little bit whenever possible. So we're going to times these two. So that's 12 x to the second plus 1. And that's it. This is again, f composite g. It's just a new function. We get it not by adding or subtracting or multiplying, but
You
by
just put
plugging
inside.
one function into the other. Yes.
No, I say you just put it inside. You replace
Mhm.
x for g.
That's right. So we plug a whole function into another. So f of g. So basically, again, g goes into f. So whatever the order is, so the second one goes into the first one. It could be f of g, or it could also be the other way around, g of f, which is different. So this one is g of f, g of f of x. So this time we're plugging f into g. So g of f, or you can write it simply like this, g of f. So now the f goes into g, not g into f. So the order in which we write this matters. So to find this, which function do we write first again?
For x positive.
That's right. So we're gonna write g first, and just leave the x blank. Just write it without the x. So for x to the second. So this is where x would be. But we remove that x. What do we put instead of the x?
3x plus 1.
That's right. So the whole function f goes into g. So this is g without the x. Instead of the x, we're going to put the function f. Function f, which is 3x plus 1. That's it. That's the function. That's the composition. It might not be as easy to simplify as this one, but you may leave it like this. It's not a problem. Here it was just one action, but here you will have to distribute this first. You can do that if you want. You're gonna have to multiply this by itself, just like we did with polynomials, 3x plus 1 times 3x plus 1, distribute the whole thing, and then multiply everything by 4. But that's not the subject, it's not the subject topic of this class. This is what we need. It looks short enough, that's not a problem. And that's it. That's basically how you get, as you can see again, they're not the same. So f of g is not the same as g of f. They are different. And they both,
Distributed.
yeah, they both basically, we can't distribute the 4 right away because we have a power here. So if you want to distribute the 4, you will have to do this first. Multiply this by itself and then distribute the 4. But again, we're not interested in that today. This is our composition. They're both, as you can see, quadratic. So the graph will be a parabola, but it's not going to be the same graph. They're slightly different. So they're going to have different, the domain is always the same for quadratic functions, but the range will change. The range, it's not going to be the exact same graph. One could be here, the other one could be, for example, up, or it could be down, or to the right, to the left. So they're not the same function. That's what I'm trying to say here. They're not the same function, but they are just quadratic functions. And whatever we do with quadratic functions, like we did last time, we can do with this. For example, I may ask you to graph this, make a table, write the domain and range in interval notation, maybe add this to another thing, add these two together, for example. They're just regular functions. We got them by combining or by finding the composition of two functions. So it's pretty simple. Again, do not confuse this with a multiplication. A lot of people do that. So don't confuse that with multiplication. Any questions, everybody, before we do another thing? Should be pretty simple to find composition of functions.
Master case is pretty complicated.
I'm sorry, say it again.
It's not easy, the last thing, f of g.
I mean, it's if you think of it as,
We'll have few samples. Any other example?
yeah, so if you think of it as, you just plug in. Okay, let me do another one. Just basically plug in a function into the other. So let's take, for example, this time f of x is 2x, or 3x, maybe 5x to the second minus 1, and another one, g of x, maybe 3x. Let's try to do the same thing. Let's find both Gonna find this one. Then we're gonna find the other one. Okay, for the first one. So what goes into what? What do we plug and where? First composition F.
Parentheses.
We plug G in X.
So it's gonna be fx plus
So
Oh,
we
We're gonna plug G,
X
no,
inside
plus G.
G of X.
It's
How do
gonna
we
be like f of G.
F of G? That's right. F of G. This is what it means, F of G. In other words, F of G. Again, just like when we plug a number into F, this time it's not a number, it's a whole function. So which function do we write first?
5x exponent
F.
F.
That's right. So write the first one, write it out. The only difference, again, you don't have to write the X, just leave the X blank. So write the first function, it is here, without the X. What goes inside those parentheses?
3x.
3x, that's right, the G. The G goes into F. This is F inside of it. And that's it. We are done. That is the composition. It takes 1 or 2 steps. The rest is just simplifying if you want to simplify it a little bit. But this is basically it. This is basically the composition. Don't worry too much about simplifying it. The important thing is basically this. Once you have it again, you can evaluate it, you can graph it, you can do whatever you want with it. So that's F of G of X. This one here is,
But sometimes the exercise, when we do the exercise, it asks you for
G of
specific answer, even if you made a little mistake, like you did point instead of comma, it gives you wrong answer.
that's right, yeah, math is very specific. There's yeah, this has to be like the exact answer. Yes, it does not recognize, for example, the computer only recognizes certain things, so it has to be like the accurate thing. But you do have like a bunch of tools and symbols you can choose from the bottom. Okay, so G of F of X. So this time, again, this is G of G goes first.
it's gonna be G 3 parentheses 5.
That's right. So G, write the G first. This is a G, so 3 times the X. Again, don't write the X instead of the X. You put the whole function X.
The whole function of G of F
Which is
5x.
is 5 exponent 2 minus 1.
that's right. Okay, that's it. And again, you can simplify it a little bit. If you want to simplify this, you're gonna do the exponent first. Before multiplying, you're gonna do this first. 3x to the second is 3x times 3x is
9x.
9x squared, right?
Yeah.
Minus 1. Then you can multiply now. 5 times 9, that's 45.
45.
X minus 1. Again, don't worry about simplifying. This is the most important thing. That's still good. You can do whatever you want with it. It's probably just as simple as this one. And this one, we can simplify it by, we can just distribute, right? And distribute. So 3 times 5x, that's 15x to the second. And 3 times -1 is negative. But again, this is good enough. That's the composition. It's composed of the two. That's why it looks like it's a composition. And that's it. So if you want to find a composition, that's how you find it. Just put one into the other. Very, just as simple as that. Okay, everybody, does that make sense? Okay, everybody else, any questions, any confusions here? Let me know. Okay, so that's how you find the composition. So if you have X here, that means you got to plug one into the other. Now, just like the previous problem, sometimes you have a number here. Sometimes you have a number. Let me go back. So with additional, for example, could be X here. That means add the two functions. Or if you have a specific number, basically instead of x, we have to plug that number in both functions with the multiplication also and everything. Same thing with the composition. You may have a specific number. In that case, we have to evaluate it. So this is basically finding the composition. Now let's see how to evaluate. Evaluating composition of functions. Just as simple, except there's a lot of trick there you have to be careful with. Let's actually work with the same. Let's work with the same function. So instead of x here, let me put a specific value. So you may say, for example, f of g of something. Instead of x, again, some number instead of x here. If you see x, that means you gotta find the composition and it will have x in it. You plug a whole function into another one. If you have a specific number here, for example, 2, the good news is you don't actually have to find a function like this. You don't actually have to find it first. You can actually find the evaluation without finding the composition itself. And this is how you do it. You got to do it in 2 steps. So if we have f of g of a specific number, you can do this without actually finding the function. If you have x here, then you have to do this. You have to plug one into the other. So you got to do it in 2 steps. The first step, basically, you evaluate this. Again, this is not a multiplication. It's not like f of 2 multiply g of 2. This is not a multiplication. This is an composition. So you got to find this first. Start by evaluating the function the closest to, or the closer to the value. So we're going to find g of 2. Okay, let's find this first, and we're going to see what to do with the value. So again, how do we find g of 2? Everybody, how do we evaluate this? How do we find g of 2? These are the functions.
Can I replace x by 2?
Okay, where do we do that?
Like, example, like
3 braces 2.
no, 3 times 2.
That's right. You're gonna plug 2 into g. That's g. You're gonna plug 2 there. It's gonna be 3 times 2. That's 6. That's the first step. That's the first step. Again, it's not like multiplication. So once you find this, which is 6, whatever you get from here, you plug into the other function, f. So we got 6, so that 6 will go here. So we evaluated this first, the result goes into f. So this 6 now goes into f. We're going to find f of 6. This 6 here, this 6 we got from the evaluation, we plug into the other one. We don't plug the same thing. We don't plug 2 here and 2 here like we did. We do that with a multiplication. Again, don't confuse those two. A lot of people make that mistake. What is it? See how, so we have a multiplication here. So we plugged 3 in both. Plugged 3 in f. In g, we multiplied the 2. It's not the same with composition. With composition, you have to evaluate this first. Whatever you get from here, you plug in this. It's not going to be the same number in both. So that's what we did here. So we found g of 2, which is 6. Now we're going to plug 6 into f of 6 again, f of 6. So we're going to plug 6 here. It's going to be 5 times 6 to the second minus 1. And when you evaluate, again, do the exponent first before the multiplication. Don't multiply yet. You got to do the exponent. 6 to the second, that's 36. And times that by 5 minus 1 would be 179. Okay, so again, when you have an evaluation of composition, start with this one. Whatever you get from it, you plug into the other one. Let me give you another example.
I have a question, Professor. It's like you have to do g first before
Yes, do the closer one to to the value, close one to the value. Let me give you another one, g of f of maybe -1. So how do we do this? What do we do? What do you evaluate?
Gonna be f. Gonna replace x by -1.
That's right. So always evaluate this one first, the closer one to the number. So we're going to find f of -1. And after you find it, we're going to see what to do with it. So then -1 goes into f. -1 goes into f. Again, f is this. So -1 will be plugged into it. And again, we simplify. So we're going to do this first. -1 to the second, which is, everybody, what is -1 to the second?
1.
+1 times it by 5.
4.
That's 5. Take away 1, 4. Good. What do we do now? Especially with that 4.
So you're gonna so you're gonna replace the x on g by 4.
That's right. So whatever you get from here, so from the first evaluation, whatever you get from there goes into the first one. So we got 4 from it. So 4 goes into g. So g of 4. Again, make sure you use the right function. Okay, 4 goes into g this time. That's g. It's going to be 3 times 4, which is 12. And that's it. That is the evaluation. As you can see, we didn't have to find the composition first. But if you have x here, that means you need to find the generic composition. But if you have a specific value, you can go around it, finding the composition by basically doing the work twice. Now, what if we have the composition? What if we have the composition already and we want to evaluate for 2? In that case, if you already have this, the composition for 2, for example, here we do have it. So it's probably convenient if we just plug 2 into it directly. 2 plugs into the composition, which is this. Instead of doing the work twice, doing 2 steps, we can actually do 2 directly into the composition, which we have, and we should get the same answer. So I suggest that if you already have the composition from the previous question or whatever, use it. If you don't have it, then you may do this. If you still want to find the composition first, even if you don't have it, if you still want to find it first, then evaluate it, that's fine too. That's not a problem. Some of you, I see that you do this. When I give you a question like this with 2, you plug the g into f first. You kind of do this first, and then you plug 2 into it. That's fine. You can do that if you want to. Or you may do it in 2 simpler steps like these. So since we already have the composition, we should have, or we could have used it. We could have plugged 2 directly into the composition, and then we should get the same answer. So let's plug 2 directly into the composition, which is here, and see that we can get the same answer. Let's do that. So plug 2 into f of g directly. So again, f of g of x equals this from the previous question. So now it's just a function, just a name, just a notation. You can call it something else, for example. You could rename it, for example, h or k or whatever, k of x or h of x. So now we're going to evaluate this for 2. Same number here, so we're going to put 2 here. Instead of x, we're going to put 2. That means that 2 goes into this, into the composition. And the composition is already here. So 2 goes basically here, so it's going to be 45. And 2, let me maybe write that in a different color. So 2 goes into the mix here. That's the mix, that's the composition. So the 2 goes into it, it goes right here. And again, simplify this. What do we do first to simplify or evaluate this? This operation? What is it? Exponent, right? exponent
180, like 179, 179.
will be 179. So 4 here, this is 4 times 45, that's 190 minus 1 would be 179. Same as the previous one. Here we did it differently. So we did it differently. Here we had to evaluate this first, then this first. But again, if you have the composition already, take advantage of it and use it. So instead of evaluating twice, or if you have more compositions, maybe more times, if you have the composition already, take advantage of it. If you don't have it, you don't have to find it first to evaluate. Again, just evaluate this first, plug it into the first. If you still want to find the composition and then evaluate it, that's fine. You can do that. That would be the same answer anyway. Okay, so we did it in 2 different ways. We got the same answer. Now let's do the other one. So g of f of -1. We did it the longer way. We got 12. How do we find the same answer using the second method? What do we do exactly? What do we need to do exactly here to find the same answer, g of f of -1? Where do we plug the -1 if we don't want to do it this way? Where do we plug it? Do we have this composition? Do we have g of f? Did we find it? Where do we plug the -1 instead of doing it this way, the second way? Where do we find, or where do we plug the -1?
15x
What is it?
to -3.
That's right. Should go here.
Yes.
That's the other composition. That's g of f of -1. Again, this is the way you do it. You don't have to do it this way. You don't have to find the composition first to do it unless you want to. But if you already have it, if you already have this, so to evaluate g of f -1, that means again, -1 goes into g of f, goes into this composition, which we happen to have. This is it, g of f is this. So it might be convenient to just plug -1 directly into this, which is here. So we can, so again, g of f of -1. So again, plug, first let me write the composition itself. So the composition we got earlier is this one, g of f of x is 15x to the second minus 3. And now, basically, we're just replacing this x, g of -1, g of f of -1. So we're replacing the x with -1, just like we do with one function by itself. So g of f of -1. Again, we're just replacing the x with -1 will be 15. So -1 to the second minus 3. Okay, so the -1. This -1, let me write it in different color also. So all we did was replace x with -1, just like we did here. So we replaced the 2 here. So we replace the 2. We replace the x here with 2. Why did we replace it with 2? Because that's what the question was. Find f of g of 2. So you can either plug it directly into the composition if you have it, or if you want to find it first, or you don't have to find the composition first. You can do it this way in 2 steps. Find this first, plug whatever you get into the other function. This will be, what is it? 12, right? So this is 1. -1 to the second is 1. 1 times 15, that's 15. Take away 3, that's 12. And again, you see that we got the same answer. So that's the purpose of the composition. Actually, it's supposed to save us time. So we don't have to do the work or the thing every time we have to do the work twice. Or actually, the composition could be longer. It could have not only 2 functions, it could be like this. G of f of k of h imagine if you have to find, for example, g of f of 2. So you have to plug 2 into h. Whatever you get from here goes into this, and then from here it plugs into that, from this plugs into this. So you do the work 4 times. But if you have this function, if you find it first, for example, hypothetically speaking, if this happens to be 3x to the 4th plus 5, this composition, after you plug in functions into functions, you got this. So instead of plugging this into this 4 times every time, it would be convenient to plug 2 directly into the composition. Plug this once to save time. That's the purpose of the composition. So you don't have to plug many times like we did here. So here, for example, it would be easier to plug 2 directly into the composition itself if we have it, or if we find it, instead of having to evaluate each one, plug into each function 4 times. So either way you do it, that's fine. You don't have to do it a specific way. Feel free to find the function first, find the composition if you want to find it first, then evaluate it. If the question says find the composition, if you have x here, then you have to find the composition. But if you have a number here, again, you can plug it directly into this and this, or if you prefer to find the function first, the composition, and then plug the number into it, that's also fine. It would be the same answer. Okay, and that's basically your composition of functions. All we're doing is we plug in a function into another, or we plug in a number into the composition, basically. It's just a notation. It just means one into the other. If the notation confuses you, you can call it h, for example. You can call this h of x, for example, and h of x equals this. It is just a new function. This is just a notation, which means plug in one into the other. So it shouldn't be confusing. Okay, any questions, everybody, about the compositions? Everyone, any questions about this part? Please let me know.
No, we're good so far.
Okay, everybody else? The silent majority. Any questions here, everybody?
I wouldn't solve it if I don't have any sample, but as long as we have.
I'm sorry, can you repeat that? I couldn't hear you.
I wouldn't solve it if I don't have a sample.
The formula.
But
what do you mean by that? You wouldn't solve it if you don't have what?
example. But we have it.
Right. So
I mean, it's not so easy.
it's really not. There's not much to it. I said there's exactly this. You either plug a function into the other, or you plug a number twice. Evaluate this, plug it into the other. That's it. So the whole thing could be summarized in this line and this line. Maybe the notation is kind of making it confusing, but it's not actually. It's really that simple. There's nothing else to it, just exactly this. Maybe you're overthinking it, but it's this simple. Don't think about anything else. Just do exactly what we just did. One step here or 2 steps. That's all. There's nothing really too complex about it, but you'll get the hang of it. You get used to it once you try it by yourself. Give you a couple examples. I'll give you an example, and we'll make you do. If you have any specific questions, everybody, about any of these steps here, please let me know. If not, I'll give you one to try by yourself. So let's have 2 functions here. And they're not always called f and g. It could be called h and k of x. And let's say 7 x to second plus or minus 5. And the other one could be, for example, 7x. So first find f plus g of x, or minus instead, not f and g, but h and k. H minus k. Okay, gotta find this first. And maybe k. And when you do this, also find h minus k of a certain number, maybe 2. And here, k times h, maybe -1. Okay, this is subtraction or multiplication, of course. Then maybe k over h of a certain number, say 3. Finally, some composition. Find f or h of k. Find the composition itself first. Or before finding the composition, evaluate it with a number. So you don't have to find it first. And then after this, find the composition. Okay, so that's your practice here. Again, just pay attention to the operation here and do exactly what it says. You may have to plug numbers to evaluate, or you may have to plug or add to functions or multiply them depending on what the question is. So give this a try. Again, look at the examples, look at everything we did. It shouldn't be that difficult. It's really pretty simple. And give you maybe 7-8 minutes to do this, and we'll discuss this once you're done. Okay, but again, try it. It's really that simple. Just look at this. Once you try it, you'll actually feel it. You'll see how pretty simple it is. Okay, so I'll see you back in a few minutes. Everybody, are you done? Everyone?
I myself not here.
Okay. Everybody else? Anyone finished? All right, couple more minutes. And again, for those who missed the quiz, if anybody here missed the quiz, send me a message here in the chat and wait after class. I'll give you the makeup. And if you have any questions about anything or the homework or whatever, please stay after class. I'll address any questions you may have. Let me take the attendance now as you work on the practice. Okay, Annie?
Present.
Farhan?
Yes, present.
Okay. Sophia?
Present, Professor.
Okay. James? James? Not here. Asia?
Yes, teacher.
Okay. Hinsa?
I'm here.
And Michael?
I'm here.
Okay. Aisha?
Present.
Okay. Anna?
Here.
Mario? Mario?
Here.
Okay. Tamara? Tamara? Not here. Shang?
I'm here.
Okay. Rashia?
I'm here.
Okay. Ayun?
Yeah.
Okay. Lady? Lady's not here. Richard? Richard? Santiago? Richard? Are you there? Sosa? Sosa? Sosa's not here. And Tangoyo?
Yes, here.
All right, let's go over these problems, everybody. And again, for those of you who have questions about anything or missed the quiz, please stay after class. Okay, what do we do here again? H minus K. What did you guys get for the answer? Everybody, H
7x squared minus 5 minus 6.
minus.
Minus 5 minus 6x.
Okay. Everybody else, you guys got the same answer?
Yep.
Okay, that's simple. Nothing to combine. For the multiplication of the two, what did you get?
I got 42x x plus 3 minus 30x.
That's right. Just multiplying these two, distributing. And for the evaluation, h minus k of 2.
At
what is
12.
that? 12. So basically, it's h of 2 minus k of 2 12, did anybody else get 12? Everybody? Nobody else get 12 here?
I've got 11 for some reason, but I have to
No,
check.
I got 11. Oh my God.
I got -12.
All right, so everybody has a different answer for some reason.
Not 11,
Oh
sorry.
no, it's that
11.
complex. H
It's
of,
11.
so H of 2
It's 11, sorry.
minus K of
11.
2. H of 2 minus K of 2. H of 2, if you plug 2 here, will be 7 to the second minus 5 minus K of 2. K of 2, you're going to plug 2 here, so it'll be 6 times 2. If you do this first, so 2 to the second, that's 4. 4 times 7, that's 28. 28 minus 5, that's 23. Minus 12, which is 11. What about K times H of negative 1?
Excuse me, the previous one, the multiplication, K.
Mhm.
The woman says it's 42x.
42, right? 42, that's right. 7 times 6, 42.
Minus 35x,
Okay, let me rewrite that.
correct? Could you
Let's
just
see. So basically
insert?
this times this times this, that's 42x to the third, minus 6x times 5, be 30x. Not
That's
Right.
what I said 42x. It's
40x.
40,
Yeah.
42. Why do I keep
when you
writing 40?
multiply 7 by 6, it equal 42x. That's what I said.
6x times 5 is 30.
Yeah,
30x, right?
30x.
Now the other one, K times H of negative 1. What did you guys get from this one? If you multiply K of negative 1 by H of negative 1, what
I
is
got
it?
negative 13.
You got 13. Anybody else got the same answer or another answer?
12.
What is it?
I've got
Same.
12.
Okay, so it's K of negative 1 times H of negative 1. Did everybody get negative 13? You didn't want to get anything different? Okay, so the next one, K over H of 3. Again, that should be K of 3 over H of 3.
I got 18 over 58.
That's right. If you plug 3 into K, here will be 18. If you plug 3 here, H of 3, if you plug 3 to the second, that's 9. 9 times 7 minus 5 would be 58, right? And then we reduce it. At least we can reduce by 2. It would be 9 over 58, or 58 by 2 would be 29, right? Which I don't think we can reduce. And that's it. So the evaluation again, we just plug it in. We don't, we just need to plug it in and simplify if possible. Okay, so this again, just addition and subtraction. Now let's move on, see the composition again. Let's
Professor,
first find
how
this.
do you read negative 13? I have a question about the result negative 13.
Yeah,
Okay, I don't know, I just wrote it down and
Yeah.
it should be 12.
12.
nobody else. That's what I was asking if you guys have a different answer, but nobody responded. So
I
let's do
said
that again. So negative 1 into K, negative 1 into K would be negative 6. Multiply negative 1 into H. Let's plug negative 1 here. Negative 1 to the second is 1. 1 times 7 is 7. 7 minus 5 is 2. So that's negative 12. This is now a composition, as you can see.
6. Oh, twice negative. So negative on negative, it's positive, no? Double.
When you multiply,
We multiply negatives.
But this is a positive.
No,
Mm.
yeah,
It's a positive number, yeah.
yeah, so it's -12, sorry, thank you.
Mhm. So let's talk about the composition here. So we have a number here and we have h. Let's first do this one without having the composition. Let's assume we don't have the composition yet, and we do this without a composition. So how do you find h of k of 3? What do we do first?
K of 3,
We plug k into h.
K of 3,
Okay, so we can find k of 3 first without having to find a composition. We're going to find a composition here, but let's do this without the composition. So number one, you're going to find k of 3. K of 3, 3 into k here would be 18. What else? What do we do with the 18 now?
H 18.
That's right. So this is 18. Now we're going to plug the 18 into h of 18. And find whatever that is. Okay, plug it to the math. It's a big number, but you can find it. Now let's find the composition. This one is a composition. There's no evaluation. So h of k of x. We have x here, that means we have to find the composition. So what do we do to find the composition? H of k, in other words, h of k. So which one do we write first? Which function do we write first to find the composition?
KX,
Oh, the
KX, no?
7x.
The h, right? The h.
Yeah, the h.
We're gonna write that down first. 7.
And put 7, 6x.
Okay, so this is h. Okay, you
7
can write it without the x.
6x.
Okay, so inside the parentheses now, what goes inside the parentheses? So this is h, we wrote it down
X,
without the x. What goes inside the parentheses?
XX.
K, K,
6x.
6.
Okay, 6x. That's it. So that's the composition. You do that in one step. Again, the next step is simplifying, but it's not a big deal. This is the important part. So you can multiply this first, multiply by 7, but this is what it is. This is what we're interested in today, the composition. Okay, that's how simple it is. Okay, this is it. This is all you need to know about the composition. These two things. Either you evaluate or you find the composition. And that's pretty much it. The rest is addition and subtraction of polynomials here. Plug the numbers and multiply, divide, whatever the operation is. Okay, everybody, any questions about the practice?